same capacitor series is weird. It's inverse, right? So then I come over to here and I say like this. And this one is going to be 1 microfarad. This is 0.8 microfarads. So then we come down to this. And this is 1.8 microfarads, and this is 3 volts. So then C is Q over V. So then that means Q, or the amount of charge overall, is CV. So that gives me 5.4 microcoulombs. And then that 5.4 microcoulombs has to be spread out over all these capacitors. So how does it do it? Well, take a look at this. What is the ratio? Oh, wow, this is weird. It's like 1 to 0.8. Wow, so what does that become? 1 to 0.8. Well, the biggest one, yeah. This is like 4/5 and 5/5. So this one gets like 4/9, and this one gets 5/9. It's a proportion. What? 5/4? Where's 5/4? Is it 5.4? Is it 3 times 1.8? Yeah, CV. Yeah, 1.8 times 3. And that was meant to throw it out there. Microcoulombs. Because charge, the unit of charge is coulombs, and then this is microfarads, so it's going to become microcoulombs. So now, take 5/9 and put it on there. So what's 5/9 of 5.4? I didn't want to try that. 3. This is 3 microcoulombs of charge. And what's 4/9? Oh, it's going to be 2.4. It's a proportion. How much charge is on this capacitor? Okay, so that means on this capacitor, right there, there is 2.4 microcoulombs, or negative 2.4 microcoulombs of charge. On this side is 2.4 microcoulombs of charge. And the other one, we know it's 3. So this one is negative 3 microcoulombs. This one is positive 3 microcoulombs. Of course, that means this is negative 3, and this is positive 3. Now, you could do it that way, or you could do it, and the cheaty way is even easier. We know that this is 0.8 microfarads, right? So the loop rule says to here and back, that has to be 0. So that means how many volts are lost here? It must be, because if this gave you 3, this has to use up 3. Using C is Q over V. Q is C. 0.8, you get 2.4 microcoulombs. What's that? Yeah, those stop there. But then there's another path here that's different. And if this is 2.4, right, because I calculated the whole thing at 5.4, then I can go right up here. And if you want to be sneaky, you see how these are both 2 microfarads? So I know the voltage across both has to be the same. So this V has to equal those 2 V's. So 3 equals 2V. So V is what? 1.5 volts here, 1.5 volts there. Q is CV. 2 times 1.5, bing, 3. Done. So you can use this, or you can just use the loop rule, whichever one you want.